Hey there, chemistry students. This is Ms. Ruark. This is Vodcast 5.2, where we're going to talk about classifying reactions or determining what type of reaction has happened, because there are lots. Okay, the basic four types of reactions. There are four basic ones that you will encounter on a regular basis. One of them is called a synthesis reaction. Synthesis means to combine or create, so combining to make one product. Decomposition reaction, and a decomposition reaction is doing just that. It is breaking down. I know my handwriting is sloppy, but I'm trying to write this quickly too. All right, then we also have a single replacement reaction. You guessed it, one thing is being replaced or swapped, and then we can also have a double replacement reaction where two things are being replaced or swapped. All right, so what are the different types? Let's go through them and give you some ways to identify which one is which. So a synthesis or a combination reaction. In a synthesis reaction, you have two or more substances that are combining together to form a single compound. There's only one product. So what's the red flag? The red flag is the thing that you're looking for that tells you that this is that type of reaction. So a red flag is that you usually just see elements, but sometimes you can see compounds, and there's only one product. This here is the red flag. One product. If you see more than one product, it's not a synthesis reaction. Okay, so an example of this is the combination of iron is Fe, and sulfur is a weird one. You know, we have those diatomics, right? We have Brinkelhoff. Okay, well, sulfur, I spelled it wrong. That's okay. Sulfur is one that it doesn't like to be by itself either, so it would be S8. S8. We can get more into that in the classroom. All right, so iron and sulfur, Fe plus S8. And that's going to give us iron 2 sulfide. So iron 2 plus 2 and sulfur with a negative 2. Guess what? Those cancel. And here is our equation. How do we know it's a synthesis reaction? Because it has one product. All right. In a decomposition reaction, you have a single compound, one compound breaking down into two or more products. It's the exact opposite of a synthesis reaction. And what's the red flag? There's only one reactant. So if you only see one reactant, you know that it's a decomposition reaction. Right? And we'll get into how to determine what types of things are made, blah, 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 blah. But just to be, start off simple. If it's binary, bi means two, so if it's binary, two elements in it, it's going to break down into the elements that make it up. So this is hydrogen and oxygen. Question, why do I have H2 and O2? Oh yeah, because of that whole Brinkelhoff thing. Remember, I'll spell it right this time. Brinkelhoff. Yes. Okay. Single replacement or a single displacement. It's the same thing. You'll hear me use them interchangeably, and it's where you have atoms of a compound, atoms of an element replace atoms of a second element in a compound. Okay, so one thing is being swapped. What's going on? You have a single element reacting with a compound. Sometimes they're going to work, sometimes they don't. It depends on the reactivity of the substance. So you have to use the activity series of metals to find out if you have a metal trying to replace another one. If it's a non-metal trying to replace a non-metal, you have to look at their location on the periodic table, and the reactivity will decrease as you move down the periodic table. Okay, we'll get more into that, the activity series and all that, and after this unit, the next unit, we'll get into that more. But right now, you just need to be able to recognize if it's a single replacement reaction. Okay, so an example here, we have aluminum. Aluminum replaces zinc, so it's reacting with zinc chloride, zinc 2 chloride actually, CnCl2, and it's going to produce aluminum chloride, AlCl3 plus zinc. Why did I put a 3 here? Because aluminum has a +3 charge and chlorine has a -1. Okay, so it's a single replacement reaction because we have a single element reacting with a compound, and guess what? One person was alone here, but they're not alone over here. Okay, I'll tell you a story about Bobby Susie when you come to class. Okay, using the activity series of metals for examples. I tell you what, we're going to skip this. We'll come back to this when we get, well, we can do it real quick. All right, how do we do this? Well, we have magnesium, and we know magnesium and zinc are both metals. So magnesium is trying to replace zinc. So you would look over here and you have your metals, and we know that we're saying that magnesium is trying to replace zinc. Well, the higher on the list it is, the more reactive it is. The lower on the list, the less reactive. So we have magnesium and zinc. Which one is more reactive? Well, magnesium is more reactive. That means that magnesium will actually come in and replace zinc. So you would end up with MgNO32 plus Zn. Zn goes home alone. Okay? Magnesium is a metal, lithium is a metal, so magnesium is trying to replace lithium. So we look here, magnesium is higher on list. Oh, lithium's not on our list. Okay, we'll come back to that one. All right. Let's do potassium and aluminum phosphate. So potassium is up here and aluminum is here. So potassium will take the place of aluminum. So it would be K3PO4 plus Al. Right. And then with these two, whichever one's higher on the periodic table, because it's a nonmetal trying to replace a nonmetal, chlorine is higher, so you would have NaCl and you would have Br by itself. Okay. And like I said, I was just showing you examples. We will get more into this in the next unit. Okay, a double replacement or a double displacement reaction is when you have an exchange of two ions between two reacting compounds. What I like to say is they're exchanging the anions. Okay, so the negatives are being exchanged. It makes it easier, right? So here you have two ionic compounds that are the reactants. And that's how you know it is a double replacement. One of three conditions has to be met. It has to make a solid. Okay, we call that a precipitate. And you would hear me say, or you might hear me say, that this is a precipitation reaction because it forms a precipitate. I spelled precipitation, not precipitate. Precipitate just means a solid. It can form a gas or it has to form water. I can't write this morning. I'm sorry. Okay, so examples of this. We have hydrogen chloride plus sodium hydroxide. Well, we have two ionic compounds. The H is going to attach itself to the OH, and the Na is going to attach itself to the to the Cl. So you end up with HOH, which is the same thing as water, and sodium chloride. Okay, same thing happens here. It attaches. They swap partners. You end up with BaCO3 and KCl. And it's okay if you wrote KCl first and BaCO3. It doesn't matter. It's the same thing. Okay. All right, so how do we identify these reactions? Just by looking at them. That's what you need to be able to get out of this. Okay, on this first one, NaOH plus KNO3, two ionic compounds. Did they swap partners? Is it NaNO3? Yes. Is it KOH? Yes. So this is going to be a double replacement reaction. Okay, and this next one, oh, that's not fair. That's a combustion reaction. We haven't covered that yet. Let's take that one out. Sorry. Okay, number 3, we have Fe plus NaBr. Did Fe attach itself to the Br on the other side? Yes. Why would it attach itself to the Br? Because it has to be a positive and a negative, so this would be a single replacement reaction. Okay, number 4, Ca attaches itself to the OH. Mg attaches itself to the SO4, double replacement. In this one, there's only one product, so it has to be a synthesis. And look, in this one, there's only one reactant, so it has to be a decomposition. Okay, we're going to do lots more practice with this. Okay, there are two special types of reactions that we're going to concern ourselves with right now. One of them is an acid-base reaction, and the other is a combustion. So an acid-base is apparently a reaction between an acid and a base. They always produce water, and they always produce a salt or an ionic compound as a product. Okay, so how do we know it's an acid? We've already covered this. It begins with hydrogen. Okay, it has to have hydrogen at the beginning. How do we know if it's a base? Typically, it's going to end with OH or hydroxide, but not always. Okay, so just be careful. Not always. Sometimes it can have carbonate, and so we'll get into that. Don't worry. But just know that for right now, if you see that it produces a salt and a water, it's an acid-base reaction. And guess what? These are specific types, very specific types of double replacement reactions. Okay, and I will show you what I mean. All right, so we have H2SO4 and KOH. So H2SO4 plus KOH. Okay, how is it a double replacement? Well, the hydrogen attaches itself to the hydroxide because the hydroxide is the negative and the hydrogen is the positive. And that gives us HOH or H2O. Same thing, right? And then the K attaches itself to the SO4, which gives us K2SO4. It's a double replacement because two things have swapped, but more specifically, it's an acid base because it made water and a salt. Okay, and we've already seen this one, I think. It's going to give us NaCl and H2O. Yay! All right, acids and bases are opposite. One is always going to be used to neutralize the other. So keep that in mind because we're going to do a whole unit on acids and bases. And if you spill an acid, you have to neutralize it with a base. If you spill a base, you have to neutralize it with an acid before you can clean it up. Okay, a combustion reaction is one where an element or compound reacts with oxygen gas. Why oxygen? Because that's what you need to burn things. If you don't have oxygen gas, you can't burn it. All right, and it produces energy in the form of heat and light. It's going to commonly involve compounds called hydrocarbons. Hydrocarbons are called hydrocarbons because they have hydrogen and they have carbon. Hydrocarbons. Ooh. All right, combustion of hydrocarbons always produces carbon dioxide and water. And the combustion will stop when the oxygen supply runs out or when the fuel, what it's burning, runs out. Okay. Do I have an example? Yes, I have examples. All right. So ethanol is C2H5OH, and you can do flame writing. However, I am never successful with this, so I will continue to keep trying, and maybe one of these days I'll be able to show it, but for some reason I just can't. I've tried for 10 years now, and every year after that I'll continue to keep trying. But it is a hydrocarbon. How do we know? Because it has carbons and hydrogens. So it's going to produce carbon dioxide and water. And you don't even have to guess. That's what it's going to produce. Methane gas, the light your teacher on fire. You guys try this every single time you have to light your Bunsen burners because you let the gas collect and then when you light it, it goes whoosh, and there's this, yeah. Or you could say light your fellow classmates on fire or light your eyebrows on fire, right? Okay, hydrocarbon, it's going to produce carbon dioxide and water. Look, it's the same thing every time. All right, and then the whoosh bottle. I'm actually going to demonstrate this one in class. And if we have methanol, CH3OH, and you take that and react it with oxygen gas, you get CO2 plus H2O. Look, same thing every single time. Okay, I think, oh, look, that's it. All right, guys, I'll see you in class.